Hello. In today's lecture, we'll try to set up IKE version 2 IPSEC tunnel between headquarter router and the branch router. So by default, we cannot ping router branch loopback address 2222 since we do not have any connectivity. And we'll try to set up that connectivity through the tunnel interface using IP 15001 on the headquarter router and then 15002 on the branch router. So let's just get started by building the tunnel interface on both routers. So we'll start on the headquarter router. Okay, so interface tunnel 0 IP address 15.0.0.1 255.255.252 and tunnel destination will be 11.0.0.2 tunnel source serial interface 2/0. Okay, and okay, so this side is pretty much set up. We assigned IP address 15.0.0.1 and we specify the tunnel destination 11.0.0.2, which is branch router serial interface, and the tunnel source is serial interface 2/0 on the headquarter router. So I'll repeat the same configuration on the branch router now. Okay, so we have specified the same configuration on the branch router. So as you can see, the OSPF neighborship is up, and we do have tunnel connectivity between both routers. As I'll try to ping 2.2.2.2, which is the IP address of the loopback branch router, and let's see if we succeed. Okay, so we succeeded. So there is adjacency. OSPF show IPSPF neighbors. You can see that neighbor address is 15.0.0.2, which is tunnel interface. So now the next section will be how to configure IKE version 2 IPSEC tunnel. So all the information is encrypted. So let's just get started on the HQ router, which is headquarters. Okay, so to set up IKE version 2, instead of doing ISACamp, we do crypto IKE version 2 proposal IKE version 2 proposal, and then we can name it anything. In our case, I'm just gonna name it IPSEC proposal in capital, so we can check if it's uppercase. That means it's user defined, not like inbuilt Cisco syntax. So we get into the configuration now. Now we have to specify the encryption. In our case, we'll be using AES CBC 256 encryption, which is quite strong. So I'm just gonna copy paste. Okay, and then the integrity will be SHA 256, and then the group command is Diffie-Hellman group. We can specify any key length. I'm just gonna go with 40. Okay, now the group is set up. Now let's just set up policy. So the syntax is crypto IKE version 2 policy. I'm just gonna call it my IKE version 2 policy. Try to be descriptive so you can troubleshoot it later. And now if you see, we just have to set up proposal here, which we already set up. So I'm gonna say I want to set proposal, which is IPSEC proposal. Remember that we did it very first step after setting up the tunnel, and then now we exit. Now we have completed two steps. So first one was the create a proposal, second one was the policy, and now we create a keyring, which is a method of defining pre-shared keys. So the syntax is crypto IKE version 2 keyring, and I'm gonna call it my keyring. Okay, and then I'm gonna say, let's see, so configure the peer. So in here we say our peer and name it. I'm just gonna say branch, which matches the name on the branch router, so BRANCH branch. And now see, we are in peer configuration mode. So let's see, so we'll specify the address. So the address of the peer is 11.0.0.2, and then subnet mask is 255.255.255.252. Okay, so now we specify the peer address, and now we say pre-share key. On the local, we'll use Cisco and pre-share key. On the remote side, um, we can keep it same or different, but whatever is configured on the branch router side, we have to match it. In my case, I'm just going to use a Cisco when I configure the branch as well. So I'm just going to configure it Cisco as well. So now the keys are configured. Now we have configured the encryption SHA and Diffie-Hellman group. Now we also specified the keys that we will be using to authenticate the peer. The next step is to configure the IPSEC IKEv2 profile. So the syntax is crypto IKEv2 profile. So profile, and then I'm just gonna name it my IKEv version 2 profile. Okay, so IKEv version 2 profile. Okay, so now I say, well, match values of the peer. Now we want to match identity, and then the remote identity, and now we specify the address of the router, which is 11.0.0.2 11.0.0.2. Okay, and then the subnet mask remote address and 11.0.0.2 255.255.255.252. Okay, now identity of the local router is the address, which is 10.0.0.2. Okay, serial interface. So hit enter, and then now we say authentication local side, we're using pre-shared key, and we're saying authentication on the remote side is pre-shared key, and hit enter. And now we can also specify the keyring here, which we created earlier. So I'm just gonna say keyring, and that was my-keyring. Okay, and now we have to specify dead period in interval, so we can see if the peer is live or dead. So hit a question mark. So we'll be sending messages 30-second, and we'll retry it too periodically. So we'll be sending hello messages on the tunnel to check if peer is still alive. Now we exit. Then now the next step is we create a IPSEC transform set. To do that, I'm just gonna copy paste. Okay, so the command is crypto IPSEC transform set, and this is the name I'm gonna choose, and this will be the encryption to encrypt the data, and this is the integrity method. Okay, and then we can specify mode will be tunnel. Now we exit. Now since we have created the IPSEC transform set 2, which will be phase 2, basically this is how you protect the data. Remember, the IKEv version 2 will be only negotiating and authenticating the peer and checking the security and matching the security parameters, but this transform set is the actual encryption method that we will be using to transfer data packets. So now it's the time we bind both of the IKEv version 2 and IPSEC transform set. Now it's time we bind both so we can use it together. So next step is crypto IPSEC profile. Now we're creating a profile, and I'm gonna call it my IPSEC profile. So we'll be in capitals. Okay, and now we say set transform set, and then transform set we created here IPSEC tset. So I'm just gonna copy this and then paste it here. Okay, now set, we already set up the transform set. Now we need to specify IKEv version 2. Remember, we're not using any ISACamp here, so let's just put IKEv version 2 profile, and then we created, I remember it was called my IKEv version 2 profile. So we can also go up and check. Okay, keyring. Okay, here's IKEv2 profile, so I'm just gonna copy paste. Okay, and now everything is done. All we have to do is apply it on the interface. So I'm just gonna exit it, and we go to interface tunnel 0. We say tunnel protection IPSEC profile, and then the name was my IPSEC profile. Um, we created here almost. Okay, don't get confused with IKEv2 profile and IPSEC profile. These two are different things. The IPSEC profile is a complete profile which also contains transfer set information, and the IKEv2 profile information. Remember, we did it here. So now I'm just gonna paste it, and I will say tunnel mode IPSEC IP version 4. Okay, and you also see the message ISEC-AMP is now on, so encryption is on. We lost the neighbor because on one side we're using the IPSEC, on the other side is still GRE. We'll repeat the steps on branch router, so I'm just gonna copy paste commands to save some time. Okay, I'm just gonna copy paste second commands. Okay, proposal is set up. Now it's time to set up the keyring. Okay, so peer is HQ, and then the address of the peer will be the address of the headquarter router, so 10.0.0.2. Okay, specify mask 252. Okay, and now the address is done, and now we say pre-share local and pre-share remote key, which is Cisco. This router will be using Cisco, another one is using Cisco as well. So copy paste, exit it. Now the fourth step is to create a IKEv2 profile, and then this commands will create IPSEC profile. Okay, exit the keyring status. Okay, profile is set up. Now set up the transform set. Oops. Okay, I made a mistake, I guess. Let's just try again. IPSEC transform set. Okay, and then say mode tunnel. Okay, exit, and now we bind both IPSEC transform set and IKEv2 profile. So the command is crypto IPSEC profile, my IPSEC profile, and then transform set is what we created here, and then in the IKEv profile that we created earlier, we exit, and then we go to interface mode tunnel 0, and then we just copy paste the commands. Okay, you see the loading is full here. So if I do show interface tunnel 0 include protocol, okay, you see it's IPSEC IP. If I ping 1.1.1.1, repeat 100 times, okay, and do show IPSEC show crypto IPSEC say, you see we encrypted 112 packets and decrypted 113 packets. Remember, 100 packets were just a ping. I can also increment it, do 100 more. Okay, see now the packets incremented by 100 because we repeated pin 100 times. So I hope this was helpful. Thank you so much for watching video. Please make sure you subscribe. Thank you.